Welcome to our presentation for Oregon State University's capstone project. Our topic was the LLM API challenge, and our product is Benny, a wellness AI companion. Our team is comprised of James, our front-end engineer, Brianna, our AI engineer, Michael, our database engineer, and William, our DevOps engineer. Meet Benny. Named after OSU's beaver mascot, he motivates, educates, and supports users in achieving their wellness goals. We leverage generative AI to create a solution that helps users take a more proactive approach to their health, fitness, and overall well-being. Benny uses Azure OpenAI GPT 3.5 Turbo for its natural conversational abilities and empathetic responses ideal for wellness coaching. The model comes pre-trained on health and fitness knowledge, eliminating the need to build our own knowledge database. Its large token window enables conversation memory for natural dialogue flow, while Azure's implementation provides privacy protection through end-to-end encryption and no data retention by OpenAI. Benny's chat interface represents the central functionality of our wellness platform. Delivering natural and supportive user interactions, we optimize the AI configuration to provide motivational responses while maintaining conversational flow through concise dialogue. We built in safeguards to ensure Benny operates strictly within wellness coaching boundaries, never venturing into medical advice. All recommendations are grounded in evidence-based wellness research, creating a reliable and trustworthy user experience. The daily check-in uses simple button selection to track your wellness consistently. Based on your responses, Benny analyzes your patterns and provides personalized recommendations tailored to your needs. All check-in data is saved to build a complete picture of your wellness journey, helping Benny give you increasingly relevant guidance over time. Benny remembers your conversations by displaying your last 10 messages in a familiar chat format similar to popular messaging apps. All conversations are automatically saved, allowing you to easily reference past discussions and pick up where you left off. This memory feature helps Benny provide more personalized support by understanding your ongoing wellness journey across multiple sessions.
I handled the front-end development for Benny. The main goal was to create a user-friendly interface that felt familiar enough with other LLM design patterns, but was also intuitive enough and had certain bespoke components for our own wellness tracking, wellness advice, daily check-ins, etc. And the main technology stack we use was React and Vite so that I could build things out fast, reiterate, and have things be modular and scalable with efficient state management. Um, I used CSS, like Tailwind CSS, for kind of a modern look. There's a lot of guides how to use Tailwind CSS, and it seemed at the time to fit in with the same visual language that I had seen on, ChatGPT or Claude or XAI or Gemini. And as the front end lead, I tried to make the app feel intuitive, just like chatting with any other AI app, and wanted to make sure that everything was reusable, modular, and avoided redundant code. So the initial planning was a mock-up done on Figma. We had spent some time researching what other apps were out there, how they had handled the user experience, and from the mock-up, I had built out the initial rough draft. And so the initial web app was very monolithic in code, and it became clear that I, I was copy pasting components over and over and over again into each page, and started to split things off. For example, the typing effect I made into its own little JavaScript hook. And as I moved into modular code, I started to run into these issues where my icons would squeeze, the header, like certain things would not render, like the header wouldn't render, and I had to make out like a layout page that would handle the individual components and then also the main pages, and somehow it was rendering things twice. And even though I had certain pages done in like Tailwind CSS with identical styling, they were different. So, a lot of the things I learned here were kind of how to make these modular components work within each other because there's a lot of tutorials that I thought, all the difficult stuff like handling session authentication and session context would be difficult, but that was pretty straightforward, like one and done almost, just following a guide step by step. Whereas, the individual bespoke stuff was where I ran into a little bit of what I would call friction. And I learned a lot on my React skills like hooks, context, being able to log in with Google basically, and then also with the design, learning to use the developer console, inspect element, and being able to reiterate fast, work up a mockup from Figma, bring it up to a rough draft, and then kind of pulling it apart and making it effective and modular. So I'm glad to have done this. Benny's great. We can build upon it. We can add so many other features to it, and the code is workable enough that this is something that you can build anything with, any AI app with. And so glad to have been part of this project, and that's the front.
Brianna developed Benny's prompt engineering strategy, creating his knowledgeable and motivational personality as a supportive wellness coach. She implemented two distinct modes. Chat mode provides research backed recommendations through warm conversational dialogue, while recommend mode analyzes daily check in data to deliver short, actionable guidance. She also built essential safeguards, ensuring Benny focuses on wellness education rather than medical advice. Brianna led the AI integration and backend development for Benny, connecting Benny to OpenAI through Azure endpoints and building a microservices RESTful API architecture. She developed four key endpoints: chat for real-time conversations, recommend for daily wellness guidance, check-in for processing check-in data, and chat recent for chat history. Her processing pipeline formats user input for the AI and delivers responses in natural conversational flow, while implementing context management for conversation memory across sessions. She used Python with Pydantic for data validation, Fast API for service architecture, comprehensive error handling, and asynchronous API calls to ensure optimal performance and user experience. Brianna's development followed a progression from concept to full integration. She began by testing and refining Benny's conversational capabilities and temperament in the Azure platform, then implemented local chatbot responses before integrating with front-end APIs for user interaction. Working with Michael's database storage system, she integrated chat logging functionality. For the recommendation system, she engineered prompts specifically for wellness guidance and developed the backend API infrastructure to process user data and deliver Benny's personalized recommendations back to users. Brianna adapted to developmental challenges by dropping our original program generation feature due to our time constraints. As someone new to AI engineering, she learned these technologies from scratch through instructional videos and Azure documentation. She systematically debugged API integration using print statements, error messaging, and AI assistance. Through this process, she gained valuable experience in chat development, creating distinct AI personalities for different use cases, and API development within microservices architecture. Michael served as our database engineer and handled backend development for database operations. He developed the comprehensive database schema supporting our entire wellness application, designing data structures for user profiles, chat conversation, and wellness tracking. Michael built a custom database connector that integrates with our backend services for real-time chat storage and retrieval. His architecture handles four key data areas: chat history, wellness preferences, customized fitness and nutrition programs, and daily check-in metrics. We initially implemented PostgreSQL with Google Cloud Hosting using Python's request package for service communication. However, we refactored to SQLite 3 for our final implementation, which proved more practical for our use case. SQLite local hosting requires only direct calls through our custom connector rather than network request, significantly improving integration with other services, reducing chat storage latency, and simplifying our overall architecture. This refactoring delivered better performance and easier maintenance for our project scope. Michael began development with the core database schema for user information, preferences, and wellness programs that formed our project foundation. We built comprehensive database functions for add, update, and delete operations. When we later decided to add chat history storage for Benny's conversation memory, the modular design allowed Michael to integrate additional tables and functions seamlessly without disrupting the existing schema. Michael navigated several key deviations and challenges during development. The team shifted from Postgres to SQLite to simplify integration with other application components because Google Cloud Hosting was difficult to integrate with our other hosted services. The original analytics component for user check-in data was dropped when our concept evolved toward qualitative data collection, making traditional analytics less valuable. During development, Michael made the decision to refactor the entire database, rewriting every table schema and manipulation function. Despite these challenges, he gained valuable experience implementing Postgres, setting up Google Cloud instances, and reinforcing his SQLite and Git skills while supporting the team through a complex project transition.
Hello, my name is William O'Brien. I handled some of the more of the full stack like project management type tasks for the group, specifically helping manage the GitHub, the CI/CD pipelines, and some of the integrated testing, and also just making the project look and feel a little bit more professional for us. So from the full stack support perspective, I helped primarily by integrating the multiple GitHub projects that our group was working on in separate repos and putting them in more of an organized structure. I also manage the main branch for stable releases, so approving a lot of the pull requests, and then also making the README flow better and describe our project and make it look very professional and well crafted. I also took our testing files and added to them GitHub Actions to make automated testing support, and then also wrote regression tests for the database files. What you're seeing here is our GitHub format and organization. For the unit testing, I so there was one well-written test file written by Brianna for the Benny AI service that was written with the Python's unit test framework. I wrote a separate test script to regression test the database file, and I put those into. I wrote separate YML files for two separate GitHub actions. One that was called run test for Benny AI service, which you see, and one test that was run test for Benny DB. This automated the testing so that anytime someone merged or pushed to the main branch, it would run these tests and tell you if they passed or failed. You could also run the test locally, which you see up here, which is the instructions in the README that describes how to do this. So that way, anytime we were merging or affecting the main branch, we could track if two of the big features, the Benny AI service and the database file, were being disrupted in any way. As far as the development journey went, for the first little bit, I started, as I said, with the CI/CD pipeline by setting up this main GitHub repo, organizing it, kind of helping make sure everything flowed between the different folders, organized the structure between the front end, the back end, the AI service, and the database, which were our four main kind of components for our project. I then went through this automated testing where I learned how to, write a YML file, upload it into GitHub for a GitHub workflow and automated action. As I said, that would help test if anything disrupted the main branch and the important components. Then the last thing I did was wrote a test file for the database file and a simple regression test and added that to the GitHub Actions. What you see here on the right in these pictures is the project structure and then also an example of what the GitHub Actions test file looked like. And as you see, it defines when this workflow runs, which is anytime someone pushes or pulls or pull requests targeting the main branch, excuse me. And lastly, deviations. We're doing more of like the overarching kind of like GitHub and CI/CD management tasks. There were really no deviations from what we planned. We were pretty on task with using GitHub and adding these testing files, and it all went very well. As far as the challenges went for me, I never worked with GitHub Actions in terms of writing a YML file and automating these tasks that requires importing modules, creating a file, and then deleting those files and cleaning up these database in the test setup. And also just that we had PyTest and unit testing in our testing framework. As far as main things I learned during this project, it was this idea of code protection with automated testing is really a cool feature of GitHub. How to interact with SQLite 3 via test writing, and also this is really the first time I've used Git in a group project with more than 2 people. So these daily pull requests, push requests, branching with bigger groups, and how do you have somebody review the code before it gets into the main branch of the group project. So that was really good to learn and be a part of. I'll also talk about the conclusion. So, I mean, overall, this was a really great project. Our group worked really well together. You know, the successes, we successfully developed the wellness AI, that we set out to do, which was a full stack wellness web app with the integrated chatbot. We deliver these key features, including the daily check-ins, personalized tips, and user authentication. And I mean, specific shout out to James and Brianna for making that front end look really beautiful and really professional. What was really cool is that we were successfully able to combine this front end, back end, this AI service, and the database all into a single platform that was reliable and scalable. So there was concern as we were going through the project of the challenges of actually combining all these different components together and making them interact. And thankfully, our group was able to make that happen. And not only did we work independently on components, but we also came together for a functioning system. There's some natural future development that we thought we would have time to do in this project, but because of the you know fast timeline, we weren't necessarily able to do. And the big one is the monthly plan development. So based on this would include something like what the user's preferences are, how their daily check-ins are going, what they're interacting with the chatbot. You could have a monthly plan that would target things like nutrition, workout, stress management, and kind of an overall 4 to 6 week plan. And then also, we didn't really have time to write a testing framework for the front end. We just didn't have enough resources and time. But what would be a great future development task is better testing using that Jest framework that can test the React components as well. So overall, that's the end of our presentation. We all thought it went really well, and we enjoyed working together. Thank you.